Students, welcome to Sunil's tutorial. I am Sunil Midwani and today we will be doing this chapter called as Chemical Thermodynamics. Let's start. Definition. Right? What do we understand by thermodynamics? Thermodynamics is defined as a quantitative relationship between heat and different forms of energy. What is thermodynamics? How do I define thermodynamics? Thermodynamics is quantitative relationship between heat and different forms of energy. Right? So when you study about heat and different forms of energy, then that is what is called as thermodynamics. Thermo means heat, dynamics means motion or transfer. So literally meaning thermodynamics is heat transfer. So when you study about heat being transferred from one source or from one form to another form, that is thermodynamics. Right? What are the limitations of thermodynamics? Limitation of thermodynamics. Thermodynamics is independent of the atomic and molecular structure. So we do not come to know the impact of atomic and molecular structure on heat and different methods of heat transfer. So first, it is independent of atomic and molecular structure. Right? Second, it is concerned only with the initial and the final states of system. In thermodynamics, we study about the initial state of the system, the final state of the system. We do not study about the process by which heat gets transferred from one form to another form. We know the initial form, we know the final form. The method of transfer and the process of transfer is not studied in thermodynamics. So the second limitation of thermodynamics is that it concerns only with initial and final states of system. Right? Next, when we study about thermodynamics, it's a macroscopic phenomenon. It is not applicable. You cannot study about thermodynamics of electrons. You cannot study about thermodynamics of protons, neutrons. You can study thermodynamics only of large bodies. You cannot study thermodynamics of microbodies. The theory of thermodynamics is not applicable to microbodies. So the third limitation is that it is the study of only macroscopic phenomena. It is a study of macroscopic phenomena. Right? Next, now when we study about thermodynamics, we only study about heat transfer. We do not study about the speed at which the transfer takes place. So thermodynamics does not tell you about the speed at which the transfer would take place. So it does not concern itself with the rate of reaction. It is not concerned with rate of reaction. And last, it is not concerned with the mechanism of reaction. All it is concerned with is the initial form and the final form. The initial value and the final value. What was the mechanism behind it? Thermodynamics does not concern itself with that. Right? So the last limitation is it is not concerned with the mechanism of reaction. these are the limitations of thermodynamics. So in thermodynamics, we are going to study about change of heat from one form to another form. Now let's see what are the basic terminologies used in thermodynamics. First, what do we understand by system? It is the part of the universe that is under thermodynamic consideration. Suppose if I have a vessel of water, I'm going to study about what will be the changes in the heat present in the water. So this part of the universe that is under thermodynamic consideration is called a system. So what is system? It is a part of the universe that is under thermodynamic consideration. Right. It is the part of the system. It is part of the universe. It is the part of the universe under consideration for thermodynamic studies. Under consideration for thermodynamic study. That is what is system. Next, what do we understand by surrounding? Surrounding. Now, leaving the system, everything else in the universe is called a surrounding. The part of the universe which is under thermodynamic consideration is the system. Leaving that part, everything else forms the surrounding. So I can say the remaining part of the universe, the remaining part of the universe, the remaining part of the universe, excluding the system, is called surrounding. Right? So you have system, surrounding. Now when we talk about systems, let's see what are the different types of system. One, you have open system. What do we understand by open system? I have a beaker, I have water. I heat water. Right? Here, as I heat water, certain amount of water will get evaporated. Some amount of heat will be exchanged with the surrounding. Similarly, some amount of matter will also be exchanged with the surrounding, because water getting converted into water vapor, that means some amount of matter is going to be exchanged with the surrounding. So what is open system? In open system, a system is said to be an open system if there is exchange of both matter as well as energy with the surrounding. If matter and energy can be exchanged with the surrounding, then such a system is called as an open system. Right? I can say that a system is said to be open if it can exchange both matter and energy with the surrounding. Matter and energy with the surrounding. This is called as open system. Next, closed system. Suppose if I have a beaker filled with water, I heat the beaker and I close the beaker with the help of a lid. Right? In this case, due to heat, some amount of water will get converted into vapor, but because of the lid, that vapor will not be able to escape into the surrounding. Now as I heat the vessel, some amount of heat will be, since the vessel gets heated, some amount of heat will be exchange between the vessel and the surrounding. So in this kind of system, there is exchange of heat, but there is no exchange of matter. So when there is exchange of heat between the system and the surrounding, but there is no exchange of matter between the system and the surrounding, then such a system is called as a closed system. Fine. A system is said to be closed system if it can exchange only energy and not matter with the surrounding. Right? Okay, next, what do we understand by an isolated system? Let's assume that I take a thermos flask. Right? I put some hot water in the thermos flask. So as a result, the temperature of the thermos flask will increase. I throw the hot water out and I put a liquid inside, a hot liquid inside, and I close the thermos flask. Right? Now, if I close this thermos flask, will there be any exchange between the matter and the surrounding? No. Will there be any exchange between the heat and the surrounding? No. Heat, the amount, because if you open the thermos flask and even after 3 hours, you will still have hot liquid inside. The liquid will still remain hot, which shows that there is no exchange between the heat and the surrounding. Similarly, there is no exchange between the matter and the surrounding. Such a system is called as an isolated system. In an isolated system, neither matter nor energy is exchanged between the system and the surrounding. Fine, do we get this in here? So I can say an isolated system, a system is said to be isolated system is said to be isolated if it cannot exchange both energy and matter with the surrounding. If it cannot exchange both energy and matter with the surrounding. Right? So these are the 3 different types of systems that we have. Next, let's see what are the different properties of system. What do we understand by extensive properties? Right? What are extensive properties? These are those properties of which the magnitude depends only upon the quantity of matter present in the system. Mass, it depends upon the quantity of matter. Volume depends upon quantity of matter. Surface area depends upon quantity of matter. Work depends upon quantity of matter. So, properties which depend upon, of which the magnitude depends upon the quantity of matter present in the system. More the matter, more different will be those properties. Those properties are called as extensive properties. Right? So what are extensive properties? The properties of the system. The properties of the system of which magnitude depends on the quantity of matter present in the system are known as extensive properties. Right? Next, intensive properties. What are intensive properties? These are properties of which the magnitude is independent of the matter present in the system. For example, pH. How acidic a liquid is. Whether I take 1 liter of the liquid or 6 liters of the liquid, will it affect the pH of the liquid? No. For example, suppose if I take normality, molarity, where the quantity of the matter does not affect the property, right? So properties which are not affected by quantity of matter present in the system are called as intensive properties, right? So let's see this properties. The properties of the system of which magnitude is independent of the quantity of matter present in the system are known as intensive properties. Right, so you have extensive properties and you have intensive properties. Next, let's see what are the different types of functions that you have. You have something called as state function. Right? What are state functions? Guys, let's assume. Let's consider a pressure volume graph. Let's assume that a system is at point A where pressure is P1, volume is V1. Let us assume that the system changes to point B where the pressure is P2, volume is V2. Now a system can change from point A to point B either by using this particular path 1, or it can change from A to B by using another path, say path 2. Right? What are state functions? State functions are those functions which depend only upon the initial and the final value of the system, and they do not depend upon the path taken by which a system changes from initial to final values. So properties that depend only upon the initial and the final value and do not depend upon the path are called as state function. Properties that depend only upon the initial and the final values but do not depend on the paths taken to obtain those values are called as state functions, right? So what are state functions? Physical quantity is said to be a state function. Physical quantity is said to be state function. A physical quantity is said to be state function if its value depends on initial and final state, and not on the paths taken, and not on the path of change. Right? Those are called as state functions. Right? Next, what are the different states of system? What are the different states of system? States of system is the condition of the set of system by changing one of which you can change the system. For example, if I consider a system is made up of pressure, volume, temperature. If I change any one of them, the initial and the final state both would change. Such group of properties are called as states of system. So states of system are a set of conditions of the system. States of system are a set of conditions of the system. States of system is the condition set of system States of system is the condition set of a system. By changing any one, the states of one of those, there would be a change in the system. The state of the system would change from initial state to final state. Right? Next, what do we understand by thermodynamic equilibrium? What do we understand by thermodynamic equilibrium? A system is said to be in a state of equilibrium if all its state functions remain constant with time. If the state functions do not change with time, then the system is said to be in thermodynamic equilibrium. Right? So what is thermodynamic equilibrium? A system is said to be in thermodynamic equilibrium if all its state function remain constant with time. That is thermodynamic equilibrium. Now, thermodynamic equilibrium is divided into multiple types of equilibrium. When we talk about thermodynamic equilibrium, you have different types of equilibrium. Thermodynamic equilibrium. It is not necessary that all state functions may remain constant. If all state functions remain constant, then that would be called as thermodynamic equilibrium. But out of the set of state functions, even one remains constant, even then there would be a certain amount of equilibrium in that. Let's see what are those different types of equilibrium. I could have thermal equilibrium. What is thermal equilibrium? A system is said to be in a state of thermal equilibrium if the temperature remains constant with time. If the temperature remains constant with time, then the body is said to have thermal equilibrium. You can say a system is said to be present. A system is said to be present in the state of thermal equilibrium if its temperature remains constant with time. If its temperature remains constant with time. That is thermal equilibrium. Next, you have mechanical equilibrium. Now, a system is said to be in mechanical equilibrium if the pressure remains unchanged with time. If the pressure of the system does not change with time, then the system is said to have mechanical equilibrium. I can say a system is said to be present in a state of mechanical equilibrium. A system is said to be present in a state of mechanical equilibrium, of mechanical equilibrium if its pressure does not change with time. If the pressure does not change with time, then the system is said to be in mechanical equilibrium. Next, chemical equilibrium. Chemical equilibrium. A system is said to be in a state of chemical equilibrium if its chemical composition remains constant with time. The chemical composition of the system does not change. A system is said to be in a state of chemical equilibrium if its chemical composition does not change with time. If the chemical composition does not change with time, then the system is said to be in a state of chemical equilibrium. Fine. Next. Now, let's see what are the different types of thermodynamic processes. Types of thermodynamic processes. In types of thermodynamic processes, you can have an isothermal process. What do we understand by isothermal process? A process which is done by carried out by keeping temperature constant is said to be an isothermal process. That means if throughout the process, if the temperature does not change, then such a process would be called as an isothermal process. A process which is carried out, a process which is carried out by keeping temperature constant, a process which is carried out by keeping temperature constant is known as isothermal process. So if the temperature does not change, then that means if delta T is equal to 0, then the process would be an isothermal process, right? Now, if the temperature has to be kept constant, that means there should be no exchange of heat between the system and the surrounding. The temperature will remain constant if there is no exchange of heat between the system and the surrounding. That means if there is no exchange of heat between the system and the surrounding, then the internal energy of the system will also not change. That means in an isothermal process, not only is delta T 0, I could say that also delta E is also 0. That is, there is going to be no change in the internal energy of the system. Right? Do we understand this? Next, let's see another process. Embiotic process. An embiotic process is a process when a process takes place when there is no exchange of heat between the system and the surrounding, then that process would be called as an embiotic process. Right? I'll just show you this. A process very similar to isothermal process. I'll show you the difference between them. A process in which no exchange of heat takes place. No exchange of heat takes place between the system No exchange of heat takes place between the system and the surrounding. Is called as Embiotic process. Finally, get this thing here. What is an embiotic process? That means it is a constant heat process. That means heat is neither supplied to the system nor is heat removed from the system. Hence, the temperature of the system, heat is neither supplied nor removed. That means for such a system, the system should be thermally isolated. It's only in the case of an thermal isolated system that you can have an embiotic process. In such a system, Q is 0, right? Or delta Q is 0, right? Next, let's see another kind of system. Let's see what is Isobaric process. Isobaric process, a process in which there is going to be no change in the volume of the system is said to be isobaric process. So if the process is carried out at constant volume, then the process is said to be an isobaric process, right? So like a process which is carried out at constant volume, a process which is carried out at constant volume is called as isobaric process. Next, the other kind of process that you can have is isobaric process. A process which is carried out by keeping pressure constant. If the pressure of the system does not change, then such a process would be called as an isobaric process. Fine. A process which is carried out at constant pressure. A process which is carried out at constant pressure. A process which is carried out at constant pressure is known as isobaric process. Or I could say that the change in pressure in this process would be 0. Fine. Next, you have cyclic process. Right? What do we understand by cyclic process? A process in which series of operations are performed and at the end of each operation the system returns back to the original state. Simple. If I heat ice, I'll get water. If I heat water, I'll get steam. If I cool steam, I'll get water. If I cool water, I'll get ice back. A series of operations are performed and at the end of which the system reaches back to its original state. Such a system is called as a cyclic process, or such a process is called as a cyclic process. The process in which series of operations are performed. Series of operations are performed and at the end of the operation the system returns back to its original state. The system returns back to its original state. Is known as cyclic process. Right? Next, what do we understand by a reversible process? Process. Right? Now, what is a reversible process? A reversible process, a process is said to be reversible under following conditions. 1. The process should take place very slowly. The process should take place in very large number of small steps. A process, there should be thermodynamic equilibrium that should be maintained in each step of conversion. Every time it changes from one step to another step, there should be a thermodynamic equilibrium, and the difference between the driving force and the opposing force should be infinitely small. I hope you all know what is driving force and opposing force. The force that converts reactants into product is called as driving force, and the force that converts products back to the reactant is called as opposing force. So if any process satisfies these 4 conditions, then the process is said to be a reversible process, right? I can say a process is said to be reversible. A process is said to be reversible if it follows the following conditions. First, the process must take place very slowly. Process must take place very slowly. Second, the process must take place in very large number of small steps. The process must take place in very large number of small steps. Right? Next, third, thermodynamic state of equilibrium must be maintained at each step of conversion. Third, thermodynamic state of equilibrium must be maintained thermodynamic state of equilibrium must be maintained at each step of conversion. And fourth, the difference between the driving force and the opposing force should be infinitely small. The difference between the driving force and opposing force should be infinitely small. Trying to get this clear? So those are called as reversible process, right? They are non-spontaneous processes. They are man-made processes, right? So these are called as reversible processes. Next, you have irreversible process. Irreversible process. What is an irreversible process? A process in which the conditions of reversibility are not maintained are irreversible process. That is, it is a process that occurs only in one direction, right? Where the difference between the driving force and the opposing force is very large, and hence the process cannot be reversed. It is a spontaneous, naturally occurring process, right? The process which not following the conditions of reversibility, the conditions of reversibility are irreversible process. Right? These processes proceed only in one direction. The process proceeds only in one direction. Right? It cannot be reversed by changing the conditions. It cannot be reversed by change in conditions. Right? So all spontaneous and naturally occurring processes are irreversible processes. All spontaneous and naturally occurring processes are irreversible process. Right? So do you understand what are irreversible processes? Right. Once you know what are reversible and irreversible processes, let's try to find out the concept of work. Now we've already learned about work in physics. How do I define work? Work is defined as the product of force and displacement along the line of action of force. So I can say work is said to be done when an object on which force is applied is displaced in the direction of the applied force. Work is said to be done when an object on which force is applied, an object on which force is applied is displaced in the direction of the applied force, is displaced in the direction of the applied force. Right, so that is what is work. Hence, by definition, I can say work is the product of force and displacement. That means I can say W is F into M. Work can be defined as the product of force and displacement. During expansion and compression of gas, the term pressure and volume are involved. Hence, the unit of work is liter atmosphere. Okay. What do you understand by heat? Yeah, heat. When you talk about pressure is measured in atmosphere, volume is measured in liters, and hence the unit is liter atmosphere. So if I am doing expansion or contraction of gas, a gas can be expanded or contracted by changing the pressure or volume, pressure and volume. Right? PV, a change in PV brings about a change in the expansion or contraction of the gas isothermally. Under isothermal conditions, if the pressure volume changes, the gas will either expand or it will contract. Now, since pressure is measured in atmosphere and volume is measured in liters, therefore the unit for work is liter atmosphere. Fine, do you get this thing here? Next, heat. What do we understand by heat? Right? Heat is the means by which a system can exchange its energy with the surrounding. Heat is a means by which system can exchange its energy with the surrounding. Fine. Now, let's try to find out the work done during an irreversible process. Work done in an irreversible process. Right? Let's try to find out the work done in an irreversible process. Right? Now, let's consider a cylinder fitted with a weightless, frictionless piston. Right? Let us assume that the cylinder is filled with gas. Gas. This is my piston. Right? This is your cylinder. So let's consider a gas fitted with a weightless piston, weightless frictionless piston filled with gas. Now let us assume. Let's just write this down. Let us consider a cylinder fitted with frictionless and weightless piston. Right? Now, let's assume that let the pressure of the gas molecules on the piston, let P be the pressure that is applied by the gas molecules on the piston, and since the piston is at rest, let's assume that the pressure applied by the atmosphere on the piston is P external. There are two forces that are going to be applied on the piston. The external atmosphere is going to exert some pressure, inward pressure onto the piston. The gas is going to exert some outward pressure on the piston. Right? Let the pressure of the gas on the piston be P, and that of the piston on the gas being P external. Right? Now there are three conditions that are possible which will give rise to three conclusions. Right? Three conditions and conclusions are observed during the expansion and compression of gas. Three conditions and conclusions are observed. Three conditions and conclusions are observed during expansion and compression of gas. During expansion and compression of gas. Right? Now assuming that this is an irreversible process, during irreversible process, right? First, either the pressure exerted by the gas is equal to the pressure exerted by piston. First condition, P is equal to P external. If P is equal to P external, then the piston will remain steady and no work will be done. Conclusion, piston remains steady and no work is done. Second condition, P is less than P external. That means the pressure exerted by the piston is greater than the pressure exerted by gas, as a result of which the piston will move downwards and there will be compression of gas, right? in which case I can say that surrounding will do work on the system, right? And since surrounding is doing work on the system, this work is going to be treated as negative work, right? Do we get this thing here? I can say piston will move down. Conclusion: piston will move downwards. Piston will move downwards and compression of gas will be observed. Compression of gas will be observed. Right? Surrounding will do work on the system known as work of compression. Surrounding will do work on system, right? Next, the third condition, pressure exerted by the gas molecules is greater than pressure exerted by the piston. Conclusion: the piston will move upwards, there will be expansion of gas and system will do work on the surrounding, right? Conclusion: piston will move upwards. Piston will move upwards due to expansion of gas. Piston will move upwards due to expansion of gas and system will do work on surrounding. Right? Now, we know that work is defined as the product of force and displacement. Now let's consider during expansion. Consider during expansion of gas. During expansion of gas, P will be greater than external pressure. P will be greater than P external. Now during expansion of gas, let us assume that the piston is displaced through a length L. During expansion of gas, let the piston be displaced by length L. Right? In which case I can say by definition we know that work is force into displacement. Right? So I can say that the small amount of work done in moving the piston dW is equal to force into small length L, right? But we know that pressure is defined as force per unit area. We know that pressure is defined as force per unit area. Therefore, I can say that force is pressure into area cross multiply. I can substitute this value in equation of work. Therefore, I can say that work, instead of force I can write pressure into area into length, but area into length is nothing but volume, but A into L, area into length, is nothing but volume. Therefore, I can say that work done is P external into volume, right? So that is going to be the work done in an irreversible process. The work done in an irreversible process, dW is P external into dV, right? So the work done during expansion of a gas is equal to the pressure exerted by the piston into the change in volume, right? The change in volume could also be written as P external into change in volume can be written as final volume minus initial volume, that is V2 minus V1, right? So I could also write this as W is equal to P V2 minus V1. So the work done in an irreversible process is P V2 minus V1, or it is also written as work is equal to P dV. Fine, do we get this? Okay, we will stop this here for the day. Thank you very much.